Hey students, Thrasher here. I am going over your momentum and conservation of momentum quiz. Well, I'm going over some of it. You have to do, of course, some of the work yourself, but I have the questions and I'm going to be giving you some tips, some ideas of how to solve these so that hopefully you work on your quiz corrections and then also maybe you glean some information for how to come on in and reassess and be more successful. So if you're watching this video, I recommend you take out your MOM.1 quiz. I'm going in order. First period to fifth period to second period to sixth period. That's the order I have in my classes. And then we'll be going over these questions, okay? So number one, you might have slightly different numbers. And again, if you were in a different class period, you might see different problems. You could skip ahead, or you could still watch this video to understand how to do these ones. It would all be good practice. But for this first question, I wanted to fill in the blanks just like we saw with that practice, those fill in the blank questions. Remember, I kind of called them little Sudoku puzzles. So let's figure this out. I want the momentum of this kid, this first person, P1. That was our first object. That's what it was in the homework. It's the same thing here. Well, I know the mass, but I don't know the velocity. I don't know what to put in right here. What about on this side? Well, I'm looking for the momentum after. They're combined. They're one thing. It doesn't label P, but I know the mass and the velocity. Don't forget, team. Oh my gosh, momentum is easy. It's the mass times velocity. Can I multiply the mass and the velocity together to get the momentum? Of course you can. That's how you fill in this blank. If I know this blank, do I know this blank? Yeah, by conservation of momentum. If I just make up a number, if this is 10, doesn't this have to be 10 if momentum is conserved? That's the idea for this quiz. Now for the next part, you had to find the velocity. Well, okay, how do I find the velocity? P equals mv. If I know the mass of the kid, and oh my gosh, I'm told the mass of the kid, and if I know the momentum, and oh my goodness, we figured out the momentum, this should be an easy algebra problem. You should be taking that momentum and dividing by the mass, and that's how you get the velocity. For number 2, it says I have 2 carts, they're moving towards each other. And it's asking, can they slam into each other such that after they hit, they end up not moving? Sorry if you saw the screen kind of jiggle a little bit, I had a little technical issue. But okay, well, let's think about it. It says, can they come back together and be stopped? That's the question. In this problem, if they're stopped, what's their final momentum? Hopefully you can tell me their final momentum is 0. If momentum is conserved, what should their initial momentum be? It should be 0, right? If momentum is conserved. Tell me, can I have 2 carts moving in opposite directions and their initial momentum be 0? You should be able to say yes. Remember, we talked about direction, positive momentum and negative momentum. So I would expect an explanation, something like how the momentums can cancel and be 0, and that's what it needs to be, because afterwards the momentum should be 0. I got a little sun in my face, that's why you see me moving my face. Oh well, I'll deal with it. That was that first set of quizzes. My next set of quizzes, I'm going to change colors. Okay, once again, fill in the blanks. I can't fill in this blank right here because I don't know the velocity. I would need that velocity to do P equals mv. But right here, do I know the mass and the velocity? Of course I do. So can I simply multiply these two things together to figure out the momentum? Yeah, you should be able to give me a quick yes. That's easy. What's the total momentum in the beginning? Well, whatever the total momentum is in the beginning, it needs to equal the total momentum in the end. So this plus this, that's my total momentum. You might have to be doing some subtraction, right? Because it looks like this is a negative number, but this combined with this, that's the total momentum after. And if momentum is conserved, that should be the total momentum here. That's how you figure out this piece, just like our homework, okay? Then it wants that velocity. Again, how do I figure out the velocity? Well, if I know the mass, and I know the mass of the bomb, and if I know the momentum, which I just talked about how to solve, you should be able to find the velocity. Okay, down here, team, oh my goodness, I don't know why so many people were confused about number 2. We saw this problem 6 separate times. This is the recoil question. We saw it with the gun a couple times. We saw it with throwing a backpack. We saw it with a superhero throwing a rock. We saw this problem over and over again. This is why things must recoil. In the beginning, what's the momentum of the father and the daughter? You should be able to tell me the initial momentum is 0. So what does the momentum in the end have to be? If momentum is conserved, and I should see that on your quiz corrections, if momentum is conserved, it should be 0. So if this father has negative momentum, what must be true about the daughter? Could they be staying at rest? No, it's not possible. You should be able to take it from there. Okay, my next set of quizzes. Notice all these problems have the same kind of setup. Yeah, different scenarios, but the same general idea. Okay, again, I'm trying to fill in these blanks. So can I figure out the momentum of this person number 1 right here? All I need is their mass and their velocity. Now, if you know their mass, it looks like it's cut off. I don't remember actually if I gave you the mass, but if I didn't give you the mass of the person, you know the total mass. If the total is 22 and the card is 4, this object here has to have a mass of 18. So I know the mass, I know the velocity. All I have to do is multiply them, this and this, in order to get this number. If you have a quiz with slightly different numbers, the process is the same, just multiply them. Now, I don't know what the velocity is of this cart right here, but if I know the initial momentum is 66, what does the final total momentum need to be? It needs to be the same number. Momentum is conserved. So the total needs to be 66. If I just figured out what this number is, you should be able to do a little bit of addition or maybe subtraction to figure out this number. That's the idea. Jumping down to my bomb problem. This is actually pretty similar to the problem I was talking about for that first set, problem number 1, or quiz letter A. I have 2 objects. One is moving to the right, one is moving to the left. They stick together. It says, is it possible for them to have 0 momentum? Well, let's think about it. If they have 0 momentum in the end, if the final momentum is 0, what does the initial momentum need to be? If it's conserved, it needs to be 0. Can the initial momentum, looking at these pictures, can the initial momentum be 0? Absolutely it can be, because you can have negative and positive momentum. I'm surprised by how many people are answering these second questions without ever talking about momentum. It's weird. Okay, these are all momentum questions. Heck, that's what the quiz is about, so it better be about momentum. So here's your explanation. It's asking, in the end, can it be 0? Well, for that to be true, the initial momentum, by conservation, must be 0. And sure, one is moving to the right, one is moving to the left. Sorry, maybe I mixed these up. If it's moving to the right, that's usually positive. If it's moving to the left, that's usually negative. Okay, that's how I had it before. So yeah, they can cancel themselves out. Yes, it is, in fact, possible. Okay, my last set of quiz questions. I'm going to jump over to another color. One more time, can I fill in the blanks? I don't know the velocity of this piece right here, but I don't actually need it. Right here it says this piece has a momentum of 16. This piece isn't moving, so what is its momentum? P equals mv. Its momentum is 0, so the total is 16. All right, well, if the total is 16 before, the total should be 16 after by conservation. Can I figure out this momentum by just doing a little bit of multiplying? Yeah, easy peasy, multiply that. And then if I know this number, how do I figure out this number? Because by conservation, the total needs to equal 16. What's this number plus this number that gets 16? That's how you answer it. Once again, how do I figure out the velocity? I need the mass and I need the momentum. Well, I know the momentum, it's 16. I know the mass, it's 2. You could solve for the velocity. These were meant to be quick little questions, just like these problems we saw on our homework. Okay, this one, number 2. A lot of people had the right ultimate answer, but they didn't have correct or at least thorough explanation. It's saying which of these 2 pieces must have more momentum, knowing that this block, after they stick together, is moving to the left. So what does that mean? After they collide, the final momentum is to the left. I don't have any numbers here, but it must be moving to the left. The momentum is negative or leftward. So if the final momentum is to the left, what must be true about the total momentum before? If momentum is conserved, there's that word again, it should be the same. So if I end up going to the left, I need to start going to the left. Well, this piece has momentum right. This piece has momentum left. If in total they need to be going to the left, which momentum has to be larger? This one does. Piece 2 must have more momentum going to the left because the total needs to be going to the left. So it's piece 2. Why? the total momentum in the beginning was to the left. So by conservation, the total momentum in the beginning needs to be to the left. So the left piece has to be bigger. Okay, remember we're subtracting here. The left piece must be bigger. So there I was quickly going through how to answer these. Hopefully that's a guide for you to both answer your own quiz question, and then maybe this also helped as a way to review and maybe do some other practice questions. That's it. That's the end. Thanks for watching.